A set which does not contain any element is called an empty set or null set or void set. If there are infinite number of elements, then it is called a infinite set. A contains 1, 2, 3, 4, B contains 1, 2, 3, 4. So the number of elements are same. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Now, in my previous class, we have discussed regarding the definition of a set and the formation of a set and few examples. Today, I am going to take the types of sets. So, let us discuss regarding the types of sets and the problems based on those types. Now, let us come to the first, the null set. Now, null means nothing, empty set, null set, empty set. That means a set which does not contain any element is called an empty set or null set or void set. A set which does not contain any element. If a set does not contain any element, such a set is called an empty set or a null set. It can also be called it as void set, void, V-O-I-D, void set. Now, let us consider for example, x such that 1 less than x less than 2. That means a value in between 1 and 2. What is the condition? X is a natural number. Then A is an empty set. See, the value which lies between 1 and 2. In between 1 and 2. So, we won't get any natural number between 1 and 2. So, therefore, this is an example for a null set, empty set. So, the next element, if you get 1.1, 1.2, 1.3 up to 1.9, these elements does not belongs to n. So, they are all not natural numbers. So, therefore, there is no element in between 1 and 2 such that it is a natural number. Therefore, this is an example for a null set. Followed, that's it. A set which does not contain any element is called a null set or an empty set. Let us consider an example. Let A is equal to x such that 1 less than x less than 1. A natural number which lies between 1 and 2. A natural number which lies between 1 and 2 is an example for an empty set because there is no natural number between 1 and 2. So, because there is no natural number between 1 and 2, therefore this is the best example for a null set. Now, let us consider other type of set. Finite set. Finite means a set which will have a definite number of elements. A set which is empty or consists of a finite number of elements is called a finite. Otherwise, it is called an infinite set. A set which contains finite number of elements. So, a set which is empty or consists of a definite number of elements is called a finite set. Otherwise, it is called an infinite set. So, for example, let us consider, let A is equal to the elements from 1, 2, 3, 4. The set of natural numbers 1, 2, 3, 4 less than 5 is a finite set. Suppose if I write another set, B is equal to 1, 2, 3, 4, 5, etc. This is an example for an infinite set. So, here the number of elements are infinite, we cannot count. Whereas here in the first set, the number of elements are finite. So, there are 4 elements, number of elements are 4. So, you can say it is a finite set. Whereas here the number of elements we cannot count. So, it is an infinite set. That means a set which contains finite number of elements is called a finite set. If a set which contains infinite number of elements is called an infinite set. Now, let us consider W. W be the set of the days of the week. Then W is called a finite set because how many days are there in a week? 7 days. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So, definitely it is a finite set, right? So, the number of the days of a week will form a finite set. So, this is an example for a finite set. This is also an example for a finite set. Whereas this is an example for an infinite set. So, in general, if a set contains definite number of elements, then it is called a finite set. If a set does not contain finite number of elements, if it contains infinite number of elements, then it is called as infinite set. Infinite set means a set consisting of infinite number of elements. So that is example 1, 2, 3, 4 is the set of natural numbers. This is an example for an infinite set. Another example, set of all even numbers 2, 4, 6, 8, etc. This is also an example for an infinite number. Another set of all odd numbers 1, 3, 5, 7. This is also an infinite set. So a set consisting of infinite number of elements is called a infinite set. These are example for the infinite set. Okay. Now let us come to the next, equal sets. When did you say two sets are equal? That is called equal set. Means two sets A and B are said to be equal if they have exactly the same elements and denoted as A is equal to B. If two sets, suppose if A and B are any two sets, the sets A and B are said to be equal if and only if A and B will have the same number of elements and exactly the same elements. Two sets are said to be equal if and only if they have same elements and the number of elements must be same, and it is denoted as A is equal to B. Otherwise, the set is said to be an unequal set. The sets are said to be not equal, unequal sets, and it is denoted as A is not equal to B. So this is the representation of an equal set, and this is the representation of a set which are not equal, unequal set. Now let us consider an example. Now let A is equal to 1, 2, 3, 4. Another set B is equal to 3, 1, 4, 2. Then here the number of elements in set A is equal to 4. Number of elements in set B is also 4. And the elements 1, 2, 3, 4. Here also 1, 2, 3, 4. We can say A is equal to B. Whatever may be the position, irrespective of the position of the element, but if the number of elements in the set A and number of elements set B are equal and the same number of elements are there, means then the set A and B are said to be equal. Now let us consider one more example. If A is equal to A, E, I, O, U, then another set B is equal to U, O, I, E, A. Here also it contains all the vowels, so we can say the number of elements in set A is 5, number of elements in set B is also 5, and same elements we have, therefore A is equal to B. Suppose, let us consider one more example. If A is equal to 1, 2, 3, 4, another 4, 5, 6, 7. These two sets, here A is not equal to B, because though there are equal number of elements, but all the elements are not same. The elements in A are 1, 2, 3, 4, whereas in set B we have 4, 5, 6, 7. Here 5, 6, 7 is not included in the set A, and similarly 1, 2, 3 is not included in the set B. Therefore, we can say that these two sets are not equal. They are not equal. Okay. Now you got an idea regarding a finite set, infinite set, null set, and equal sets. Now let us come to the problems based on these. Okay. Now exercise number 1.2. Which of the following are examples for a null set? Now first one, set of odd natural numbers divisible by 2. Set of odd, ODD, odd natural numbers is divisible by 2. Odd numbers means numbers which are not divisible by any other number except one and the same number. So that means then those numbers are not divisible by 2. So the odd numbers, for example 3, 5, 7, these are odd numbers. We cannot divide this by 2. So this is not possible. We cannot divide. Does not belongs to the set. So therefore does not belongs to the set of natural numbers. So therefore this is an example for a null set. The first one is a null set. We can say the first one is a null set. Which of the following are example for null set means odd natural numbers divisible by 2 is an example for a null set. Okay. This is an example. Okay. Now let us come to the second example. What is the second example? Set of even prime numbers. So here A even prime number, 2 is an even prime number. So this is not a null set. This does not belongs to a null set. This is not a null set. Okay. The even prime number, since 2 is an even prime number, so it is not a null set. Okay. Now next, What is the next example? X such that x is a natural number, x less than 5 and x is greater than 7. So x is a natural number less than 5. Natural number less than 5 is 1, 2, 3 and 4, and which is greater than 7. X is greater than 7. That means there is no simultaneous element which is less than 4 and greater than 7. So therefore this is an example for a null set. This is also a null set. There is no element less than 5 and simultaneously which is greater than 7 is an example for a null set. So this is also a null set. Next, another set. What is given? Y such that y is a point common to any two parallel lines. Y is a point common to any two parallel lines is an example for a null set. This is also a null set. Okay, that's it. Y is a point common to any two parallel lines. So there is no common point parallel to two parallel lines. There is no common point parallel to two parallel lines, hence it is a null set. This is also an example for a null set. So that's all. That means the set of all natural numbers divisible by 2 is an example for a null set. The set of even prime numbers, because 2 is a prime number, this is not a null set. Whereas x is a natural number less than 5 and greater than 7. There is no number simultaneously less than 5 and greater than 7. This is a null set. And a point common to any two parallel lines. Two parallel lines does not have any common point. So therefore this is also an example for a null set. So first, third and fourth are null set, whereas the second one is not an example for a null set. That's all. Now let us come to the next concept. Which of the following sets are finite or infinite? So here, first one, the set of months of a year. Since there are 12 months, how many months? 12 months are there in a year. Therefore, definitely this is an example for a finite set. Right. The number of months in a year is 12. Therefore, this is a finite set. The set of months of a year is a finite set. Here, the set of natural numbers 1, 2, 3, 4, 5, etc. This is infinite number of elements are there. This is an example for an infinite set. Infinite set. The set of months of a year is an example for a finite set because there are 12 months in a year. Now, here, second one, 1, 2, 3, etc. There are so many numbers. We don't know how many numbers are there. Therefore, this is an example for an infinite set. So, the first one is a finite set. Second one, infinite set. Second one is an infinite set. Now, third one, 1, 2, 3, 4, etc. 99, 100. So, there are 100 numbers, the numbers. So, 1 to 100. So, here, therefore, this is also an example for a finite set. See, the elements are all natural numbers from 1 to 100. 1, 2, 3, 4, 5, etc. The last number is 100. Therefore, this is an example for a finite set. Whereas the set of all positive integers greater than 100. Set of all positive integers greater than 100. 101, 102, etc. we don't know. So, therefore, this is an example for infinite set. So, this is also an example for an infinite set. And the last one, the set of all prime numbers less than 99. So, there are only few prime numbers which are less than 99. So, therefore, we can say that this is an example for a finite set. This is a finite set. See here. The set of all months of a year is an example for a finite set. 1, 2, 3, 4, etc. is an example for an infinite set. And 1, 2, 3, 4, etc. 99, 100 is an example for a finite set. The set of positive integers greater than 100 is also again an infinite set. Infinite. The set of prime numbers less than 99 is a finite set. This is a finite set. So, first one is a finite, second one is infinite, third one is also a finite set, and the fourth one is infinite set, and the last one is finite set. So, if the number of elements are finite, then it is a finite set. If there are infinite number of elements, then it is called a infinite set. That is according to the definition of a finite and infinite set. Let us come to the next concept. in the following state whether A is equal to B or not. So whether we have to say whether they are equal sets or not. Now what are given? So here first one, A is equal to A, B, C, D and the set B is equal to D, C, B, A. See here, the number of elements in the set A is same as the number of elements in the set B. A contains 1, 2, 3, 4, B contains 1, 2, 3, 4. So the number of elements are same. Whether if they have same elements, then we can say A and B are equal. So here A is there, we have A, B, B is also there, C and D. So the order is different, but we have same elements, but the order is different. Therefore, this is an equal set. A is equal to B. A and B are equal. The set A is equal to B. Now let us come to the second one. What is the second set? The number of elements are same. And what are the elements here we have? Check whether the same elements we will have in both the sets A and B. A contains 4, B also contains 4, A contains 8, B contains 8. And whereas A contains 12, B does not contain 12, A contains 16, here 18 is there. So since A contains 12, but B does not contain 12, whereas B contains 18, A does not contain 18. Therefore, these are not equal set. A is not equal to B. Here, A is not equal to B. Okay, so here we have 12, which is not in the set B. We have 18, which is not in the set A. Therefore, A is not equal to B. These two sets are said to be not equal. Just equal in size, but they are not equal. So, here you can say 12 belongs to A, but 12 does not belongs to B. Okay. Now, let us come to the third one. A is equal to 2, 4, 6, 8, 10 and B, X is a positive even integer and less than or equal to 10. So, what is A contains? A is equal to elements of A are 2, 4, 6, 8 and 10. What is the statement given? B is equal to, what is B? X is a positive even integer and less than or equal to 10. Even numbers less than or equal to 10 are 2, 4, 6, 8 and 10. So, here A contains 2, 4, 6, 8, 10 and B also contains 2, 4, 6, 8, 10. Therefore, we can say that A and B are equal. So, here A is equal to B. Okay. Here see, A contains all the even numbers less than 10, 2, 4, 6, 8, 10 and the statement is given even integers less than or equal to 10 are nothing but 2, 4, 6, 8, 10. So, therefore, set A is equal to set B. Here this itself is nothing but set of all even positive integers less than or equal to 10. Now let us come to the fourth one. A, X such that X is a multiple of 10 and B, what is B? B contains multiple of 10. 10 into 1, this is not a multiple of 10 because 15 is a multiple of 5, 5 3s are 15. So therefore this is not equal. Here A is not equal to B. This set A is not equal to B because 15 does not belongs to A. 15 is not a multiple of 10. Okay. So these are the examples for the sets whether equal or not. See here, the set A contains same elements A, B, C, D and A, B, C, D. Therefore, A and B are equal. First set is equal to second set. They are equal sets. Whereas the second set A contains 4, 8, 12 and 16, B contains 8, 4, 16 and 18. 12 is included in the set A but 12 is not there in the set B. Similarly, 18 is included in the set B but 18 is not in the set A. Therefore, they are not equal. A is not equal to B. And whereas the third set 2, 4, 6, 8, 10, the statement is given positive integers less than or equal to 10 is nothing but 2, 4, 6, 8, 10. Therefore, it is a equal set. And whereas X is a multiple of 10, this is not a multiple of 10. So, these are the multiples of 5. So, we can say that these two sets A and set B are not equal. Okay. Now, let us come to the next set of problems. So, what is the problem given? Are the following pair of sets equal? Whether we have to say whether the following pair of sets AB is given. So, and give reasons. We have to give the reason. The first one. What is the first one? A. The set A contains 2, 3. whereas the set B contains, what is B? X such that X is a solution of, now this is a quadratic equation. Let us solve. X square plus 5x plus 6 is equal to 0. So the factors of 6 are nothing but 3 and 2. So this can be written as x square plus 2x plus 3x plus 6 is equal to 0. Here you can take x common factor, x plus 2. Here 3 common factor, x plus 2 is equal to 0. The factors are x plus 2 into x plus 3 is equal to 0. Therefore, x is equal to minus 2 and x is equal to minus 3. So, here x contains minus 3 and b contains minus 3 and minus 2. See the difference? See, A contains 2 and 3. B also contains 2 and 3. But in A, all the elements are positive, whereas in B, they are negative elements. We can say that A is not equal to B. They are not equal because A contains positive numbers, whereas B contains all the negative values. So, A is not equal to B. Okay. See, I will explain once again. A contains 2 and 3. B contains the solution of this set. It's a quadratic equation. Factorize this quadratic equation. X square plus 5x plus 6 can be written as the factors of 6 are 3 and 2. So, 2x plus 3x plus 6. 2 plus 3 is 5x. X is the common factor, x into x plus 2, plus is the common factor, x plus 2. The common factors are x plus 2 and x plus 3. You can solve. What are the factors? Roots we are going to get is x is equal to minus 2 and x is equal to minus 3. So, therefore, the set B contains minus 3 comma minus 2, whereas the set A contains 2 comma 3. In set A, we have positive integers, whereas in set B, we have negative integers. So, therefore, A is not equal to B. According to the definition, if A contains 2, 3, B also contains 2 and 3. Or if it A contains minus 2, minus 3, B also contains minus 3, minus 2. So, this is different. Therefore, they are not equal. They are not equal sets. Now, let us come to the second problem. A, x such that x is a letter in the word follow and whereas y is a letter in the word wolf. Now, let us come to the second one. So, in second, what we have A contains. So, this can be written as F, O, 1 L, L is already there, O is already there, we can write W. So, F, O, L, W and B contains, what are the letters of the word B? We have in B, wolf, W, then O, comma L, comma F. See, so since A contains 4 letters, B also contains 4 letters, whereas yes, A contains F, in B also we have F, O is there in B also, L is also included in the set B, W is also included in the set. So, therefore, we can say that A is equal to B. So, these two sets are equal, whereas these two sets are not equal. That's all. So, first one, A is not equal to B because the solution of x square plus 5x plus 6 is not equal to A. The second one, the letters of the word follow are F, O, L, W, whereas the letters of the word wolf is W, O, L, F. Since this contains same elements, therefore, A is equal to B. The first set is not equal and the second set is equal. Okay. Now, let us come to the next problem. Now, same question number 6. From the set given below, select the equal sets. What is to select here? We have to select the equal sets. Observe carefully. What is A contains? A contains 2, 4, 6, 12. Just see, the number of elements are 4 and the same elements. Check the set which contains 2, 4, 8, 12. So, this is not equal because it contains 1, 2, 3, 4 but not same elements. Set C contains 4, okay, 8, 12 but 14 is there but this is not the set. So, here 2, 4, 8, 12, 4, 8, 12, 14. So, then D contains 3, 1, 4, 2. So, here A is not equal to any set. Let us come to the set B. B is equal to 1, 2, 3, 4 and come to set D. What is D contains? D contains 3, 1, 4, 2. Observe carefully. 1 is included in the set, 1 is also there, 2 is also there in the set and 3 is also there in the set and 4 is also included in the set D. Therefore, we can say that set B is equal to D. So B and D are equal sets. These two sets are equal, B and D. Okay, so B contains 1, 2, 3, 4. D also contains 1, 2, 3, 4. So therefore equal sets. Now let us come to this set. G, E and E. What is E contains? E contains minus 1 comma 1 and G contains 1 comma minus 1. See here. So E contains minus 1, G also contains minus 1, E contains 1, G also contains 1. So straight away you can say E is equal to G. So the set E and the set G, these two sets are equal. And what about the other sets? In F, we have 0 comma A, whereas in H, 0 comma 1, F is not equal to H, and similarly A is not equal to C. So we can say A, if you want, you can say A is not equal to C and F is not equal to H. Because the elements of F are 0 comma A, the elements of H are 0 comma H, whereas the elements of A are 2, 4, 8, 12, whereas the elements of C are 4, 8, 12 and 14. So these two are equal set, whereas the remaining two are not equal sets. So just what is to say, from the following sets given below, select the equal sets. The equal sets are B and D are equal set. Similarly, E and G are equal sets, whereas these two are not equal sets. So that is how we are going to solve. Okay, that is regarding the example for a finite set, infinite set, null set, as well as equal sets and the few problems based on this. These are very simple concepts and very easy. So you may expect a few questions from this exercise. Okay, so that's all for today's session. Let us meet with a different concept in the next session. Thank you very much.